discuss a new topic, that is actuators in robot. Note here actuators. So that is, actuators are the devices which provide actual motive force for the robot joints. That is the actual motive force that are provided by the provided to the robot joints. They commonly get their power from one of the three sources, that is compressed air, compressed oil and electricity. We already discussed that topic in the module 1. That is, if it is a compressed air, then we call it as a pneumatic drive system, and if it is compressed oil or fluid, we call it as hydraulic drive system, and if it is electricity, we call it electric actuator. Okay, let's see pneumatic and hydraulic actuator. Actually, pneumatic and hydraulic actuators both are powered by moving fluids. We already discussed, that is, in one case it is compressed air, and in the second case it is compressed fluid. So let's see, in the first case the fluid is compressed air, and in the second case the fluid is usually pressurized oil or fluid. Okay, the operation of both pneumatic and hydraulic are similar except in their ability to contain the pressure of the fluid. Only the difference, that is, if we have more load carrying require more load carrying capacity, etc., so we go for a hydraulic drive system. Otherwise, for a desktop type or a pick and place with a low weight, we go for a pneumatic drive system. Okay, then pneumatic operation usually operates at 100 pounds per inch square, and if we go for a hydraulic system, it operates at 1000 to 3000 pounds per inch square. Okay, already we discussed the advantages and disadvantages of both systems in module 1. Did you remember that? Okay, anyways, we studied drive technology, that is the classification of robot. We classify the robot based on work envelope, drive technology and motion control. In drive technology, we further divided the robots into pneumatic, hydraulic and electric. Okay, so you can see a figure here, that a simple fluid power device, which is a cylinder, actually used for to actuate a linear joint by means of moving piston. It is a single-ended cylinder, as the piston rod only comes out of the cylinder at one end. Also, we have double-ended cylinders or rodless ends. Okay, based on the diagram, you can see there is a piston in the one side of the cylinder. When we apply a pressure to that particular portion, we can see there a small you can see a small hole on one of the point, and if we apply a pressure to that particular point, the fluid becomes compressed, and the piston will move to one of the to one side. So thereby we get a linear motion. So that is the principle behind a single-ended cylinder, prismatic cylinder. If we use air instead of fluid, we call it as pneumatic, and if we are using a fluid instead of air, we call it as hydraulic. Actually, there are two relationships for this type of cylinder. One for velocity of actuator with respect to input power, and the second one force of the actuator with respect to input power. And that's the relation V of T is equal to t by A, where V of t is the velocity of the piston at that particular time interval, and F of t is the fluid flow rate. F of t is the fluid flow rate, and A is the area of the piston. So totally V of t is equal to F of t by A, where V of t is the velocity of the piston and F of t is the fluid flow rate and A is the area of the piston. And the second relation, that is F of t. F of t is equal to P of t into A, where F of t, that's capital F of t, F of t is the force and P of t is the pressure of the fluid and A is the area of the piston. So these are the two relationships that can be calculated from the single-ended cylinder or from the double-ended cylinder also. So V of t is equal to F of t by A, and F of t is, capital F of t is equal to V of t into A. Okay. Also you can see another cylinder, that is double-ended cylinder there. In this case, we apply the pressure to the center region so that we get a linear movement to both piston at the both ends. It gets movement for the piston to into two directions. Okay, and also there is another type of actuator, that is van actuator, which can provide a rotatory actuation. Rotatory actuation. You can see the diagram of a van actuator. That is okay. So these are the two types of actuators which provide an active motive force to the robot joints. That is pneumatic and hydraulic. And there is one more left, that is electric. In electric, we classify it into DC as well as AC servo motors and stepper motor, which we will see in detail in the next class. Okay, thank you.